Hey folks, welcome back to the series where we build a video call app with durable objects. So far, we've set up the app front end and we'll be building on top of it in this video. If you missed the last video where we did the front end setup, here's a link to go catch it. Now, in this video, I'm going to show you how to make a WebRTC call and also how to answer a WebRTC call. It's going to be really awesome. My name is Confident and I'm a developer advocate at Cloudflare. Let's get started. All right, before moving on to writing code, I think it makes a lot of sense to show you conceptually what we'll be doing in this video and the next few ones. So we're going to be setting up a WebRTC connection to make a call and answer a call that is also going to allow for audio and video pass-through. And I have a timing diagram to give you a conceptual model of what we'll be doing when we go to start writing code. So I have this diagram. I think a larger preview should be showing on the screen right now. And here you notice we have two clients. We have client 1 and we also have client 2. For simplicity, I'm going to call client 1 Rob and client 2 Emma. And if you've ever made a call over your cell phone, this is the exact same thing. So you make a call, someone has to answer the call, a negotiation has to happen to figure out the best way to connect both clients together. And when that's done, you can actually start talking and the other clients can start hearing what you're saying. So that's the exact process. But interestingly, we'll be writing this in code, which is really awesome. So let's get ready to write this in code and it's going to be really awesome. So we're going to start with making a call, and making a call involves creating a peer-to-peer connection. So Rob creates a peer-to-peer connection with Emma, and then uploading the local stream of the current client to the connection. So Rob uploads his local video stream and audio stream on the connection. And then Rob also has to download the audio and video stream uploaded by Emma on the connection to the app and then have it displayed on the UI. So that's virtually all we're going to be doing here. So to get this done, we already know that when a connection is established, we're going to receive a joined event. So let's start by handling the join event to make a call. So what I'm going to do is head back to the handle message function. And here we want to create a switch statement. All right, so this switch is going to switch on msg.type. All right, so if we receive a type of joined, all right, we want to go ahead to make a call. So this is going to be a wait, make call. We don't have this function yet, so we have to go and create it. So I'm going to create that function here. So this is going to be an async function, make call, and we don't have any params. So for the body of this function, we want to do a couple of things, like I said earlier. We want to establish a peer-to-peer connection between both clients, so between both Rob and Emma. Then we want to go ahead to create a configuration for our local environment and also share that with Emma. So Emma has to know what Rob's local environment looks like so that she's going to be able to connect to him. So let's create a connection first. This is going to be wait, so connect to pair. All right, it's a function we haven't created yet, so let's go create it. So this is also going to be an async function. Connect to pair, and it is not going to have params. All right, for the body of this function, what we're going to do is first create a WebRTC connection. So I'm going to save this into the pair connection variable. So this is pair connection equal to new RTC pair connection. All right, and we're going to pass our env.servers. So the stun servers we created earlier is going to be a public service. In this case, we're using Cloudflare's stun server. Let's go take a look at what that is. So we're using Cloudflare's stun server, which we have just above in the configuration. Where is that? Okay, this is it. So we're using Cloudflare stun server, and it's a service that is going to allow us figure where we are in the network stack and also where the other client is in the network and help us like communicate to each other, help us form a peer-to-peer connection so that we can start exchanging video and audio streams. So that is what a stun server is in a nutshell. You can read up on this if you'd love to learn more, but we have our stun server, so we have a connection there. I'm just going to pass that server configuration to the RTC pair connection so that we have that service to use to figure out where we are in the network and also where the other client is in the network. And then we'll need to create a media stream for the remote pair who is going to be joining. So imagine this is Rob's computer. Rob also has to create a remote stream for Emma, such that when we get Emma's video and audio, we're going to be able to add it to the remote stream. So this is remote. We already created this variable earlier. So this is the remote stream variable equal to new media stream. All right, that looks good. Then the next thing we want to do here is we want to display the remote stream on the pair video elements we have on the app. So this is going to be pair vid dot src object, and that's going to be the remote stream. All right. Then the next thing we want to do here is we want to remove the height class so that it's visible. So this is going to be pair vid.class list.remove. So we want to remove height. Then the last thing we want to do is we want to make our own video preview smaller. So Rob wants his own video preview to be small, whereas Emma's video should be big. So let's add a class that is going to do that. So on my video, so this is my vid, want to add a class. So this is going to be class list.add. Want to add a class that is called video player secondary. All right, so this class is already defined in the CSS file. You can take a look at what it does if you'd love to learn more. Then we want to ensure that our local stream is running. So if we don't have a local stream, if this variable is not set, we want to call the start local playback function we created earlier. So that's going to ensure we have a local stream, and then we can take our local stream and upload it to the pair connection we just created. So this is going to be local stream dot get tracks. All right, and for each track, we want to add that track to the connection. So what I'm going to do here is I'm going to take the remote stream. So what I'm going to do here is I'm going to take the pair connection and upload all of my local tracks or local stream on top of it. So this is going to be pair connection dot add track, and we want to add a track. And where is this coming from? This is coming from local stream. All right, so that's how we upload our local stream on the connection. The next thing we want to do is we want to download the remote stream from the other calling client so that we'll be able to display it on the app. So Rob is making the call. Rob wants to be able to download Emma's video stream on audio stream so that it's going to be visible on the app. So this is the code that does that for us. So this is pair connection dot on track. All right, this is going to be a function that has an event. And what we want to do is we want to get the first track, which will represent Emma's local stream, which in this case is going to be our remote stream. So this is going to be e.streams. This is index 0. And what we want to do is get the tracks, all right, just like we did for our remote, just like we did for our local stream. I want to do a for each here, for each, all right. So for each track, what we want to do is we want to put that track on the remote stream. So this is going to be remote stream dot add track, and we want to put that track, and that's done. So the next thing we want to do is we want to be able to send configuration from our client to the other client to help them figure out the best way to communicate with us. So when we receive those ICE candidates, that's what it's called. It's a protocol that allows two pairs to find and communicate with each other over WebRTC. When we receive those ICE candidates, we want to send it to the other pair. So if Rob generates new ICE candidates, which is the configuration we're talking about, we want to send them over to Emma so that she's able to receive them and add it to our connection so that her client knows how to connect to ours. And the same thing happens when Emma generates new ICE candidates. We want to be able to receive them and add it to our connection so that we figure out the best way to form a peer-to-peer connection with Emma. So let's write the code that does that. All right, so when we have a pair connection, we want to listen for the onIceCandidate event. So this is on IceCandidate. And what we want to do is, whenever we receive an IceCandidate, we want to send it to the other client. So what I'm going to do here is check if we have an actual candidate. If we have a candidate, e.candidate, all right? What I'm going to do is send it over to the other client. So let's call WS send, and let's set the message type to candidate, all right? And the candidate is going to be e.candidate. All right, so that's how we send over the IceCandidate configurations from one client to the other client, and this looks good. So before moving on, because we'll need to handle the case when we receive an IceCandidate, right? Before moving on, let's finish our make call function. So we have a connection established to the other pair. Rob has a connection to Emma. The next thing we're going to do is create an offer. So this is going to be const offer equals await pair connection dot create offer. All right. Then we want to add that offer to our local description, which means we're creating some configuration. We want to add it to our own connection and then also send it over to the other client so that they can have that added to their own configuration. So let's do that. This is going to be await pair connection dot set local description. All right, we want to add the offer to our local configuration, and then we want to send it over to the other client. So Rob is going to send an offer to Emma, and Emma has to accept the offer. So this is going to be WS send. The message type is going to be offer. All right, and then we want to pass the offer across. All right, so that looks good. Now, the next thing we want to do is we want to handle the case when we receive IceCandidates, right? So we have a connection going and our client has generated some IceCandidates. We want to be able to send it over to the other client. So Rob generates IceCandidates. We want to be able to send it over to Emma. I want Emma to be able to receive those candidates and accept them. Same also goes when the situation is reversed. So let's, I'm going to fold this because I don't think we need to have that open anymore. I'm also going to fold this. So let's go back to the switch statement here. We want to add a case when we receive a candidate, all right? So when we receive a candidate, what we want to do is accept the candidate. So wait, accept candidates, and we are going to pass in the msg.candidate. All right, we need to create a function to get that going, but before that, we want to add a break here. All right, so that's good. Now let's create a function to accept a candidate. And I'm just going to ensure we have some space over here so you can see the code properly. All right, so this is going to be an async function. All right, and it's going to be called accept candidate. We are going to have a candidate. And basically what we're doing here is a try-catch block that is going to try to accept a candidate. So if you have an error, we're simply going to console.log. We can say something like error adding IceCandidate, and then we can pass the actual error message. Then in the try block, we're going to try to accept the candidate. And how we do it is by calling the add IceCandidate method on the pair connection. So this is going to be wait pair connection.add IceCandidate, and we pass in the candidates. So that's all we need to do. So we have the case where we receive IceCandidates from a connection. We're able to add it. The next thing we want to do is when we receive an offer. So Rob makes an offer, sends it over to Emma. Emma should be able to accept the offer to start a call. So let's handle that case when we receive an offer, because remember the make call function creates an offer and sends it over to Emma. So Emma has to respond to this offer to start a call. All right, so let's go back up here. And what we want to do is add a case for offer. All right, when we receive an offer, we want to answer the call. So Emma received an offer from Rob. Emma wants to answer the call. So this is await answer call. And we want to pass the msg.offer. And we also want to break here. All right, so that looks good. And what I'm going to do is over here, I'm just going to create a new function called answer call. All right, and this is going to take the offer. All right, so this is going to be what Emma does to answer a call. So the first thing we want to do is also create a connection, a WebRTC connection back to Rob, and then we can do the whole call answering process. And you'll notice that this is going to be similar to the make call function we created earlier. So this is a wait, connect to pair, right? Create that connection to Rob. And then we want to take that offer and add it to our remote description. So this is going to be a wait, pair connection dot set remote description. We want to pass in the offer. All right, that looks good. Then we're going to create an answer, which is also an offer. So let's say const enter equal to pair connection dot create answer. All right, we have that answer created. We're going to set that answer to our local description so that we have that configuration added to our local end of the connection. So this is going to be wait, pair connection dot set local description. We want to pass the answer. And lastly, we want to send that answer back over to Rob. So this is going to be ws send. This is going to have a type of answer. And we also want to pass the answer. All right, and that's how you answer a call. So we have this answer call function, which is very similar to the make call function. Now, when we receive an answer, so Emma has answered the call, what we want to actually do is start the call. That's going to be the last step here. So let's write some code to start the call. All right, so we are going to come over here, case, when we receive an answer, all right, we are going to execute a function to start the call. So this is going to be wait, start call. We don't have this created yet, but we're going to pass the message.answer to this function, and we're also going to break here. All right, so I can fold this. Let's also go ahead to fold this. All right, that looks good. And here, I'm going to have a function called start call. So start call is going to take the answer. And what start call is simply going to do is set the answer, which is also an offer, to the remote description of the answering client. So the answer is created by Emma. Emma is going to send it over to Rob. Rob is going to take that answer, which is also an offer, like I said earlier, and add it to his remote description, or set it as his remote description. So this is going to be wait, pair connection dot set remote description, and we have that answer. All right, and that's it. That's the last step of the puzzle. So let's go into see if this works. I'm going to head back to the browser and let's refresh everything and see if we're able to make a call to someone and that person is also able to join the call. So let's head back to the browser. All right, this is the window. I think I can go ahead to close this, and I'm going to reload the screen. So let's reload. All right, this looks good. We're still in this durable objects call room. And then I'm going to create a new tab. So let's go to localhost. We'll paste in the meeting link and we click on the join button. All right. And as you can see, okay, so what I just quickly did is, let's reload. Okay, so I think I need to enable mic. But what I was trying to do is stop the microphone so that you don't hear that weird echo. So I'm going to enable mic, but what I'll do is heading back to the code here where we're requesting for audio. So let's find audio. Okay, so here where we request for audio, I'm just going to set this to false. All right, so that we don't sends the audio stream, and we don't have that weird issue where there's a lot of echo in the video. So I'm going to reload this. I'm also going to reload this. Yeah, and as you can see, we have the video coming through, but we don't have the audio so that you don't hear that weird echo. But we're going to fix that in the next video when we wire up the buttons over here. But you can see it works. So we have two clients on this call. So this is Rob's window, and so this is Rob's tab, by the way. But you can see Rob's preview over here, which is really small. So Rob only needs to have a small preview of his video. Then the other video, which you see here in a bigger preview, that is Emma's video. And if you head over to Emma's tab, this is Emma's preview, but this is Rob's video showing up here in the big window preview. So everything we have set up is working nicely, and I'm happy that this is really cool. So we're making a web call over WebRTC, and we're able to make the call. Emma is able to answer the call, and we're able to start a conversation, and you can see all of this happening in real time, which is really awesome. In the next video, we'll handle the situation where a peer leaves the call, and we'll also write some code to wire up the call control buttons that are on the page. Don't forget to get subscribed so that you don't miss our next video, and I'll see you in the next tutorial. Take care. Bye-bye.